All right, good afternoon, everybody. So we're now at the point in the course where we can read and write from a file. We can do dynamic memory allocation. We basically covered everything we need to cover in the course to this point. So finally, we're now prepared to actually do some real systems programming. Right? So this is CISC 220 systems programming. End of week 11, we're finally going to do some system programming. So what we're going to do today is implement some of the command line tools that we used in Bash. Implement approximations of those tools. The tools that come in Bash are fairly sophisticated, right? They have lots of command line options. They can do lots of different things. I'm not going to try to implement all the options. So I'm just going to implement the bare bones version of some of these tools. All right, so one of the things I did not teach you in the Bash part of the course is you can copy a file without actually using CP. Right? You can copy a file by catting the file to standard. So you can, sorry, let me give you an example here. So there's a file on here called SUMFile. Right, so if I cat SUMFile, what does cat do? It reads the contents of SUMFile and outputs it to standard output. Right? You can make a copy of that, or I can copy SUMFile by using redirection. Right? So I can redirect standard output to another file. Right? And if I look at copy, copy is a copy of SUMFile. Right? And so that's one way to copy a file. You don't actually have to use CP. You can, in fact, use cat. Right? And just to generalize it a little bit more, right? Remember that cat will read from standard input, so the keyboard, if you don't give it any arguments. So remember that operator right there redirects the contents of a file to standard input. Right? So this redirects the contents of some file to standard input, which cat reads. Cat then writes its output to the copied file. Right? And so that also copies a file. Right? And the funny thing in Linux is that Linux makes no distinction between whether or not a file is text or binary data, right? Zeros and ones. Right? It just reads in bytes of data. So cat literally reads in bytes of data, and then if you're redirecting it to a file, it just writes out, the redirection writes the bytes of data to the file. So you can copy any file in Linux like this. The basic idea here is that if you can read from standard input and write the characters that you're reading to standard output, you can copy a file. So we can implement a bare bones version of the CP command using the following. Right? So if I'm happy to use redirection, I can copy a file. All I have to do is read standard input, right, until there's no more characters left to read. Right? As I'm reading standard input, I can just write the characters to standard output. Right? And if the user uses our program with redirection, they can effectively copy a file. And so we can easily do this now at this point in the course. Right? We know how to read a file. We know how to read from a file stream character by character. Right? That's just fgetc. Right? And so this is easy to implement. So CP220. CP220.c is our bare bones implementation of copy using redirection. Right? So basically, I'm going to read from standard input until I can no longer read from standard input. Right? So that's just a little while loop. Right? Okay. Now remember, how do you read a file? One character at a time. Right? So remember, our condition here, we're going to try to read a character. So we're going to use fgetc. Right? We're going to assign the red character to C. Everything has to be inside parentheses because we want to look at the value of C to compare to determine whether or not we've read to the end of the file. Right? Now fgetc takes in the file stream. Right? Which file do you want to read from? Right? So normally you would open a file first and then call fgetc, but don't forget your C program opens up 3 standard streams when you start the program. One of them is standard in. So I can read from standard in without having to open it myself. Right? And so while we can read a character, right, now remember how fgetc works, right? It returns EOF on failure. Right? So if it hits the end of the file, fgetc will return the value EOF. Right? So while it's not EOF, I know that I successfully read in a character. Right? Now I want to take that character that I read in and write it back out to standard output. So what function writes a character to standard output? Well, fputc will write a character to standard output. So fputc You tell it which character to write. I want to write C. You tell it which file to write to. I would like to write the standard output. Like that. Right. And you're done. That's it. Right? So here I've done no error checking. So I'll come back in and fill in the error checking in just a second. Right? But I think that I claim that this program here will in fact copy characters from standard input to standard output. So let's see what happens when we try to compile and run this program. What's this called? CP220. Okay, so let's see if this works. CP220. So it'll read from standard input. So I'm just going to redirect the contents of some file to CP220. Right? It writes to standard output. So if this works correctly, it simply outputs the contents of some file. Right? So basically, our program that we just wrote here is basically cat. Right? Well, cat for one file. Right? Does it work? Can I redirect that to copy the file? Right? And the answer is yes, you can. Right? And so there is a very, very bare bones implementation of copy, assuming you're willing to use redirection, input and output redirection to actually perform the copy. Okay, if you want to do error checking, you want to test whether or not you want to test the return value from fputc, right? So fputc fputc returns EOF if it fails to write the character, right? Oh, sorry. So if that is equal to EOF, right? There's an error, right? So if there's an error writing to standard output, something bad has happened, right? No way to recover from that, right? So you should do something. So something like return, exit the program somehow, right? From the main method, you can always return from the main method, and that will cause the program to exit. So I'm going to return with the exit status 2. Don't forget, if you wanted to print the error message, you can. But if there's an error writing to standard output, there's probably going to be an error writing to standard error 2. So the next line is probably not useful, but if you wanted to, you could write the following. Right, so remember, p-error will print an error message. So it prints this string, followed by whatever error message corresponds to what caused that error there. Right? So you can try printing the error. Probably not going to work if you can't write the standard output, but I guess for completeness we can do that. Right? And finally, it's possible that when you're reading from a file, reading from standard input, an error has occurred, which would also be weird, but I suppose it could technically occur. Right? So if that occurs, fgetC will return EOF. Right? It might be useful to know if an error occurred when reading. Right? So you can test if an error occurred using ferror. Right? So ferror tests the specified file to see if an error has been raised when using that stream. Right? And if that's the case, again, something has gone wrong while trying to read the file. So you could, if you wanted to, output an error message. Something like error reading from standard in. Something like that. That part is probably unnecessary because the error message probably already includes that information, right? And then exit with some non-zero exit status. So I'm just going to return 1 in this case, right? And so if you wanted to do all your error checking, that would be one way to do it, right? And that copies the file using redirection. Now, if you want to copy a specified file to another specified file, all you have to do is change the program so that it uses the command line arguments. Right? So if you wanted to specify the 2 files, right, then your program looks like the following. Right? You're going to open the input file for reading. Right? You're going to open the output file for writing. Right? And then you're going to read the input file 1 character at a time. Right? So while reading a character from the input file succeeds, right, print the character to the output file. Right? When all of this is done, right, don't forget you should close your files. So close the input file and close the output file. There aren't very many changes to make to this program here. Right? So here you change that to int argc, comma, char star argv, square bracket, right? You check to see if there's the appropriate number of command line arguments, right? And then you open up the files using the arguments that were passed to the program, right? So without doing any error checking, I'm just going to copy this. Oh, you needed standard I/O so that we can use fputc, fgetc, and ferror and perr. Okay, so if you want the version of the program that can where the user specifies the input and output file, it looks like the following. So no error checking. So whoever arg count has to be 3. I'm going to assume that that the user has passed in a valid input file name and valid output file name. So assume valid inputs. Okay, so let's do it this way. So char star f in. So that's going to be argv1. Right, so that's the name of the input file. The name of the output file is 2. Right, I want to open up the files for reading and writing, so I need to do this file. So f in, f open, in. Yep. Okay, I want to read. So the input file I want to read, so I need to open it in read mode. Right, and then the output file I'm going to write to, so I have to open up that in write mode, right? And now the rest of your program doesn't change very much. Fgetc, instead of reading from standard in, I'm going to read from fin, right? And instead of writing to standard out, I'm going to write to fout. Here I'm going to test whether or not fin had an error. I guess I should change that from input file, like that, right? And then I guess we should be nice and close the files. Well, this is for completeness sake. Again, this is just a main function, so when the program exits, it's going to close the files anyway. But just to emphasize the fact that you should always close a file when you're done with it, I'm going to do that. Right? And assuming I did everything correctly, no guarantee that I did. CP. What am I going to call this? Also CP 220. Okay. So if I did all of that correctly, we should be able to compile that. Yes? Okay. And then when we run it, we can do something like some file. So that's the input file, and copy is our output file. Okay, no errors. And what's in copy? Oh, sorry. Okay, so it looks like I did everything correctly. It actually works. Right. And so there's the very bare bone versions of copy. Right. To actually implement copy, you have to deal with directories and other things like that. And to do that, you'd have to go. You'd have to figure out how can you process directories and things like that in C. And you actually can't in C. You have to rely on the operating. You'd probably rely on the operating system libraries to know how to read and write directory contents. All right, so that's copying a file. So basically the only thing that's happening here, right, is that you're reading one character at a time, right? That's basically how this thing works. Any questions? All right. So you could also do this in a line-oriented way, right? So in other words, you can say, well, look, maybe if I'm copying a text file, it probably consists of lines of text, which means you could do this in line-oriented as well. So instead of using fgetc, right, you can read in lines of text. So let's try to do that. So I'm just going to copy this again, because it's going to be similar. I'm going to make a new file. I'm going to save that as, so I'm just going to save that as LCP220. So this is line-oriented copy. Okay, so for line-oriented input, remember you need to read your lines into a string. So instead of a instead of a character here, or an int in this case, right, I need a string. So I'm just going to call the string a buffer, right? And So for the simple version of this program, I'm going to assume that no line in the file is longer than some arbitrary value, right? So I'm going to pick 4096, right? So I can read in lines of at most 4095 characters. Oh, wait, sorry, this shouldn't be here. This needs to be inside main. Right? We'll fix this in a later example program, right? So we'll be able to read in lines of arbitrary length a little bit later on. Okay, now I want to do line-oriented input. So instead of fgetC, I want to use fgets. Right, so remember, fgets is the function that reads a string, from a file. Right. So I guess instead of using 496 up here, I should make a variable. Oops, sorry, like that. Like that. And if you remember from yesterday, fgets will read in, the day before. Fgets will read in at most max minus 1 characters, right? Reads in max minus 1 because it needs to write the end of line, the end of string, the null terminator into the buffer because that's a string. Right. We want to read from standard in. Right? Fgets returns that. So it returns a pointer to your array or to your string. If it succeeds, if it fails, it returns null. So as long as this is not null, right? Let's strike the. Oh, right. Okay. So if we successfully read in the string, we can just write the string back out, right? And so that's just fputs. Right. So fputs takes in the string to write. Right. It takes in the file to write to, and that's it. It also returns EOF if it fails. Right. So if it fails, fputs failed, right? Like that, and the rest of it stays the same. This is going to be standard in. So this was fgets failed. And the rest is exactly the same. Right? So rather than character-based input, you can do line-based input. Right? Like that. And away you go. Right? This isn't exactly this is not exactly line-based input. This is trying to consume that many characters at a time. Right? Fgets fgets reads in individual strings. So it reads in, reads in individual strings, right? So it reads in at most that many characters minus 1 each time. All right, so that's the string-based version of CP. Right? It also works if you try it out. All right, so what else can we do? So there's copying a file. So there are a lot of the other tools we looked at earlier in the course, they all work on files or strings, right? So if you remember the tr command, right? Tr is the command that translates characters from one set to another set, right? So you can easily implement that as well, right? So the idea here for tr is you want to your TR program needs 2 inputs, right? So it needs the set to translate from and the set to translate to. Right? So include. So I need standard I/O because I'm doing I/O. I need. It's going to be useful to have string in this case because I may need to use some of the string functions. So we want a little program that has 2 inputs. Okay, so 2 inputs, so if our count is not 3, right? Because remember, one of the inputs to your program is always the name of the program. Right? So if it's not 3, there's an error. So I want to write to standard error, the message tr2220, set 1, set 2, like that. Right, so we need the characters to translate from, right? The corresponding characters to translate to, And then we're going to use redirection to read in a file. Okay, so the characters to read in from, so that's set 1, is just argv1. Right? And the string containing the characters to translate to are just coming from argv2, like that. Right. Okay, so remember the way that tr works. That set cannot be longer than that set there. Right? Those are the characters to translate to. Right? These are the from. Right? These are the characters to translate to. Right? If there's more characters to translate from than there are to, right? There are characters that we don't know how to translate in the first set. So we should test whether or not set 1 is greater than, the length is greater than set 2. Right? So if, string length. So size t. Sorry. So the length of string 1, string length. Right? And the length of string 2, right, is that, right? If 2 is less than 1, right? So if the second set is shorter than the first set, that's a problem. I don't know how to translate some characters from the first set into the second set. So I want an error message and exit. So set length of set 2 is less than length of set 1. Right. Exit with a different code so that people can have some idea what went wrong. Right. And now I want to read from standard input, right, 1 character at a time. Right. Every time I read a character from standard input, I'm going to search the first set for that character. Right. If the character is in that set, I'm going to translate it to the corresponding character in the second set. Right? Now, remember, how do you search a string for a character? There's a function called strchr. Right? So I'm not going to do the error handling in this this time. Right? So, int. So cin and int cout. Right? So remember, in this case, we're reading a character. And then we're going to write a different character, possibly a different character, if the character that we read in is in this set, right? We're going to translate it to a character in this set and write out a different character. So here it's useful to have 2 variables, cin and cout. Okay, so I'm going to try to read into cin. Cin equals same character-based loop that you would write in normally. Sorry, fgetc. Standard in. Right, so while you can read a character from standard input, search for the character in standard output. So I'm going to assume that the character that we read in is not one of the ones we want to translate. So I'm going to set cout to cin. Right, so remember how tr works. If the character is not in set 1, then it just gets repeated. That character just gets repeated on standard output. Okay, so now I want to test, is cin in set 1? Right, and so strchr, set 1, cin. Right, so remember that function there searches that string there for that character there. Right, it returns a pointer to the character in the string if it finds the string. If it finds the character. So res is my pointer to the character in set 1. Right? If it doesn't find cin in set 1, it returns null. Right? So here I'm interested in, did it not return null? Right? Because if it didn't return null, then I have to translate cin to a different character. Right? So if res, right? So in other words, if cin appears in set 1, right? I want cout to be the corresponding character in set 2. Right? So cout is going to be equal to some character in set 2. Now how do I get the index of the character in set 2? Right? So remember, res is a pointer into set 1. Right? So I can get the index by taking res and subtracting set1, like that. Set1, is that right? Yes, that's right. Right. So there I'm using pointer difference, right, to compute the index. Right. So now I've got my output character. Now I can just write the output character. Cout to standard out, like that. Right. And that loop there. Oh, sorry. Right. And so that loop there reads from standard input one character at a time, right? Testing whether or not the character matches the character in set one, right? If it doesn't match the character, it simply writes the character that was read into standard output. If it does match the character, it finds the corresponding character in set two and then writes that character to standard output. I guess we should return 0. Right. Oops, sorry. And this is going to be TR220. Okay, so assuming I typed all that in correctly, this hopefully compiles and runs and does what we want. So GCC -O. Okay, that's good. All right, so the way you use this program is you redirect some, I guess we should do set one and set two. So hang on, let's take a look here. What's in, I don't know what's in some file. Hang on. Oh wait, there's numbers. What's here? Yeah, that works. Okay, so TR, I'm going to translate every 0 to a 5. Numbers. Oops, not TR, sorry. TR220, like that. And it works, right? So every 0 in numbers gets translated to a 5, right? If you want to translate the 1s to 2s, you can do that, right? So the 0s get translated to 5s, the 1s get translated to 2s, and away you go. Right? And of course, if you wanted to change the comma as well, go ahead and change the comma to something else. How about a space? No, space is not going to work, right? Well, does this work? No. It does work. There you go. Right? And so there is your bare bones implementation of TR. Right? Again, it's all built on the fact that you can do a surprising amount of stuff just by reading in a file one character at a time. Right? All right. Any questions so far? No? Okay. What about the cut program? Cat students. Okay, so there's a file that is tab delimited. Right? So it has 3 columns of data where the columns are separated with a tab character. So that right there is a tab, that's a tab, that's a tab. Right? So remember how cut works. Cut lets you specify one or more columns to obtain from a column delimited file. Right? So for example, cut minus F1, students would extract the student numbers. Right? Cut minus F2 would extract the last names. Cut minus F3 would extract the first names. Right? And a cut is fancy. You can specify multiple columns to extract. Right? I don't want to be that fancy. I just want to extract the first column. So how do you implement a bare bones version of cut where you only extract the first column? Right? Again, reading everything from standard input. Right? And so the basic idea here is, again, read the file or read standard input one character at a time. Right? So when you encounter a tab, right, that's where you know you've got the, read standard input one character at a time. If the character is not a tab, print the character that you read in. Right? When you get to the tab character, so when I get to here in this file, right, I want to ignore everything in the rest of the line. Right? So I don't want to print out everything else in the file, everything else on that line. Right? So when you reach this point here, you want to read the file one character at a time until you reach the end of the line. Right? So now you're looking for the new line character. Right? When you read the new line character, now you're back to printing the characters, reading and printing the characters one character at a time, right? Until you see the tab, right? In which case you ignore everything else until you see the new line character, right? And then go back to reading and printing the characters. Okay, so this is going to be my bare bones version of cut, right, where I can only cut the first line, the first column of data. Right. Okay, so again, I'm just going to ignore the error handling. Right. So we're going to build this using our standard loop. Right. So C equals F get C standard in, not EOF. Right, so read the file one character at a time. Right, if the character is the tab character, right, I want to ignore the rest of the line. Right, otherwise I want to print the character that was read. Right, so if C is equal to, so the tab character is \t. Right, so now inside the loop, I want another while loop. Right? I want to continue reading the characters until I find the new line character. Right? So I'm just going to repeat that. Right? Until I get to the new line. Right? So the new line character is \n. Right? So now that I've read the new line character, I can get out of this loop. Right? I've consumed the rest of the line, so I can break out of this loop. Right? And then I can, I guess I should do else here. No, hang on just a second here. C, yes, right. F put C standard, C standard out. Okay, this line is sneaky. All right, so here, so what happens here if, this is interesting. There's a slight bug in this. This doesn't work if there's no columns, if there's no columns in the file. Sorry, if the first column is missing. So in other words, if your file starts with with a tab, this is buggy. So watch out for that. Otherwise, it works. So if there is in fact a first column of data, right? It reads in a character up here, right? If it's not a tab, it prints it out down here, right? When you get to the tab, right, we continue reading until you hit the new line character, right? And so now when you exit that loop, it prints the new line character here, so it goes to the next line. Right? But it is buggy if the first character that you read in is a tab, right? The first character in each line happens to be a tab. That's going to print the tab character instead. Which might be what you want. So if the first tab is missing, there is no data. So I guess there's nothing in the first column. So I guess that is okay, in fact. And return. So this is, what is this? This is cut one. Cut one because I can only cut the first column. Okay, so does this thing actually work? Let's take a look. Cut one, pipe in numbers. So if this works, I should get, if I can type, if this works, I should get the 1,000, 1,001, and 1,000. Oops, sorry, students, not numbers. There we go. Right. So it does in fact give you the first column of data here. Right. If you wanted to search, so some obvious extensions here are to be able to read in more than one column, to be able to cut a range of columns or a specified column. Right? And to do that, you'd have to now you'd need inputs into the program to let the user pass in that sort of information. Right? But it's not terribly hard to do. So you fairly easily adapt this program to read in specified columns. All right, I guess one more example. We'll call it quits for today. So this one's fairly long. We may not finish this one. I think on one of your assignments, I asked you to use the command called rev. So remember what rev does. So rev will read a file and then print the file by reversing the characters in the line. Right, so in other words, it prints out each line of the file where each line is printed out in reverse order. And it's kind of funny. So you might wonder why this is one of the standard tools. So this is actually part of GNU Core Utils, right? It's one of the fundamental tools that comes with any GNU distribution. And this seems like a weird function to include, or a weird command to include. The reason it's here is because every once in a while, you want to solve a programming problem where it's easier to work from the end of the string rather than the front of the string, right? And so if you reverse the string, sometimes that makes your problem a little bit easier to solve, right? In particular, quit please. So let's look at that students file again, right? So cut, the way cut works is you have to specify which column you would like to cut, right? So 1 says I'd like column 1, right? 2 says you'd like column 2, and 3, of course, says you'd like column 3, right? The problem with cut is that there's no way to cut from the end, right? So if you have a file and you don't know how many columns of data it has, right, there's no good way to say, hey, I'd only like the last column of data, right? Here I need to know that there's 3 columns of data in order to cut the file, right? So if you're in the situation where you don't know how many columns of data you have, but you would like the last column, right, the solution is to reverse the file. Pipe the output to cut, right? Extract the first column of the reversed file, which is your last column, right? And then pipe that back to reverse, right? So re-reverse the output, right? And now you get the last column of the data, right? So there's a simple example of when reversing a string makes it possible to solve a problem. This time using a tool that's normally set up to cut from the beginning. There's other examples too. So this here, this file numbers contains a bunch of numbers that are written, where the numbers are written with commas, separating every group of 3 characters, right? But the groups of 3 start from the end of the string, right? They don't start from the front, right? So when you write down these numbers, you don't write 100, comma something, right? You group the thousands, then you group the millions, and so on and so on and so forth, right? And so if you wanted to replace these commas with something else, or you wanted to work with convert this string into a real number, right? It might be easier if you reverse this string and go the other way. Sorry, let me back up. If you wanted to write out numbers without commas this way, right? So you have a file where there's a integer in the first column, but it doesn't have commas in it, right? And you wanted to put the commas in, right? It's much easier to reverse the numbers in the file and then stick the commas in every 3 characters, right? And then reverse the output again, right? If you had the numbers 1, 1,000, 1,000,000, and 10,000, right, and you didn't reverse the strings, it becomes much harder to figure out where do you want to insert the commas, right? So there's a uncommon set of problems where it's easier to work from the back of the string than the front, but that's why Rev exists, or one of the reasons Rev exists. So how do you implement Rev? And so, if you're willing to live with, if you're willing to assume that the lines in your file have no, or there's an upper limit to the length of the lines in your file, it's relatively easy to do. If you want to be more sophisticated about it, and you don't want there to be an arbitrary upper limit, it becomes harder to do. So I'm going to try to solve the harder version of the problem. It's not going to happen in 10 minutes. It's going to take too long. Okay, so let's begin, and then we will probably complete this in the next lecture. Okay, so I need standard I/O because I need to read and write. If I don't assume a maximum line length, then I need to reverse a string. I need the entire string. So if I'm not assuming an upper limit on the line length, I have to dynamically allocate an array to hold the string. So I need standard lib now, because standard lib is where realloc lives. Right? Furthermore, if I'm working with a string, it might be useful to have access to strings. So I'm going to include string here. I'm not 100% sure if I actually need it. In main. Okay, so this is going to reverse one file, right? So we're going to read the file with redirection. We're going to write the file to standard output. Okay, so I need buffer to read a line into, right? And the problem with rev is that you really do need to read the entire line, right? You can't read part of the line because you need to reverse the whole string. So you might start by writing this, right? But you'll quickly realize that this is not going to work, right? So here, if I do that, right, I'm stuck reading in lines of no more than 15 characters, right? I need the zero. I need the extra character for the null terminator. And that's not going to work, right? You might say, well, I can reallocate that buffer, but you can't, right? You can't reallocate this. It's not a dynamically allocated string, right? So you cannot use a plain old array. Right, so that's not going to work. So instead, what I need is I really do need a dynamically allocated array here. Right, so car star buff equals. So I'm going to use malloc to allocate the buffer, and I'm going to create a second variable. Size that stores the current size of the array that is pointing at. Okay, I'm going to do malloc size, but don't forget you, in general, you need the size of the element, right? So here, you might also write multiply by the size of car, right? But then you remember size of car is 1, so maybe that's not necessary after all, right? But remember, if you're allocating an array of doubles, multiply by size of double. Okay. So that's my buffer. Buff is going to be the array that I'm going to read into, right? I'm going to read the file one character at a time, right? As I read characters, I'm going to populate this array, right? When I hit the 15th or the 16th element of the array, right, or the sized element of the array, right, I have to remember that I need to reallocate this array if I have to read in more characters, right? And so in this in the loop that I'm about to write, I'm going to have to deal with reallocating buff. Right? So read input. Sorry, one character at a time. Right, possibly reallocating buff as we go. Okay, so how do you read a file one character at a time? Well, it's the same old thing, right? So while c equals f get c, f. Standard in is not equal to EOF. Okay, so inside the loop, so if we get to the loop body, we've read in a character, right? Now you want to know, have I read in the entire line, right? So in other words, do I see is C the new line character? Where is C? Sorry. I don't have C, right? I did not. Okay. So I could read into a character C. I'm going to be a little bit fancy. I'm going to do the following instead. So rather than writing into C, I'm going to try to write directly into my array. Right? And so I'm going to make a pointer C in this case. Right? So C points at the element in the array where I can now write the next character into. Right? So it's going to point at the beginning of the array. Right? It's a pointer, so I need to deallocate it. Dereference it when I use fgetC. Right? And so that writes into the array element pointed at by C. Right? So slightly fancier than before, right? But not terribly, not much more. Right. So if star C is equal to the new line character. Right. So if I see the new line character, I've read in the entire line. Right. Can now reverse buff. Right. Okay. Now I just wrote. So remember what's happened here, right? I read in a new line character and actually wrote it into the array, right? When I reverse the string that's sitting in buff, I don't want to include the new line character, right? The new line character is not part of the, is not going to be, when I reverse it, I don't want the new line character to be at the front of the string, right? So I'm going to replace the new line character with \0 instead. So star C equals like that, right? And now I can reverse the string. Right, so how do you reverse a string? You want to write a little loop, right, where you have an index at the front of the string and the back of the string, and you want to swap those two characters, right? And then you want to move those two indexes, the first one forward, the second one backwards, right? And so I guess we will, what time is it? Yeah, let's stop there. So I'll reverse the string in the next lecture. Down here, I'll show you how to reallocate buff as we go, right? And then finally, we'll write the output when we at the end, right? All right, and so Monday's lecture, we'll finish this off. We'll implement a few more command line tools. And then I guess on Tuesday? Yeah, Tuesday. We'll wrap up the course, and there'll be no lecture next Thursday. All right. Any questions about today's lecture? Yes? Sure, I could. Yeah, no problem. All right. Anything else? Okay, done for this week. I don't remember if I put the announcement on OnCue or not. The next assignment is out. There's also another, if you look at the assignment, it says something about the last day in which it's accepted.